Welcome back, Algebra 2. Let's go ahead and start section 5.5. We're going to divide 5.5 into two parts, 5.5a and 5.5b. They're both kind of the same main topic. We're going to go ahead and divide polynomials. So if you remember in 5.3, we went ahead and we added, subtracted, and multiplied, and we didn't really do division. So we're going to come back to that. All right, so for part A, we're going to use long division. And if you kind of want to, if you're curious, we're going to do 5.5b involving a thing called synthetic division. Okay, it's not really helping my case because we talked about imaginary numbers a few weeks ago. Now we're talking about synthetic division. I promise they are both, despite the names, despite the very bad choice of names, I promise they're both very real and very, in our case, useful, okay? Synthetic division, after we do long division today, you're gonna love synthetic division tomorrow, I think. So I guess we'll see. So our objectives for today are to, let's first, recall long division from elementary school. We're going to kind of see how that worked, and we're going to see how that applies to when we use it to divide one polynomial by another, okay? We're going to get into polynomial division, and that's going to help us since in 5.4 we talked about factoring. This idea of division, factoring is reversing multiplication. Well, so is division. So division is going to help us to factor whenever we're not able to factor just by looking at it and using the techniques that we've learned so far. Okay, and so we're going to then make a connection between dividing polynomials and factoring. All right, so blast from the past time. Let's go ahead and just do a little bit of long division with numbers like we did back in elementary school. So let's just remember, let's say that I wanted to take the number 3,427 and divide it by 15. So if my problem was divide, so do 3,427 divided by 15, if that was my question, if that's what I wanted to figure out, then this is how I would set it up. Okay, so just to remember a few vocabulary terms, they're going to help us when we apply them to polynomial long division. This 15, since it's what you're dividing by, is called your divisor. This 3,427 is what you are dividing into. That's called your dividend. Dividend. It's a fun word to say. And then whatever answer we get, so whatever we get here, that's going to be called our quotient. Quotient, quotient. All right. So just kind of remind yourself of these words, and we're going to need to, we're going to talk about them again when we get into the actual long division of polynomials, okay? So let's remind ourselves of how we used to do this back in elementary school. Okay, so if I wanted to divide 15 into 3,427, the first thing I would do is, okay, how many times does 15 go into 3? Not at all, so I move on. How many times does 15 go into 34? Okay, I can fit 15 into 34 twice because 15 times 2 is 30. So 15 times 2 is 30. I subtract off 30 from the 34. And what does that give us? 4. Okay, and then the next thing I did is I brought down the 2. So now I'm seeing how many times can I fit 15 into 42? Well, it's actually the same amount because if I do 15 times 2, that's 30. If I do 15 times 3, that is 45. So that's too big. So I want to stay below 42, which means that it's another 2. Okay, so 2 times 15, that's another 30. Subtract that off. 42 minus 30, that's 12. And then I bring down the 7. Okay, so now for the last one, how many times does 15 go into 127 evenly? Well, if you do little calculations in your calculator, you'll find that that is 8 times, because 8 times 1, I was going to say 115. 8 times 15 is 120. Okay, so if I go up to 9, that's going to put me at 135, and that's too big. Okay, so I'm at 8. And if I subtract these, I end up with 7. Now there's no more numbers to bring down. I've brought down the entire 3,427. So when I'm asking this, there's a couple different ways I can report my answer. I can either say, well, this is equal to 228 with a remainder of 7, right? R7, remainder, that's how much is left over when you've divide it into the whole number. Now, I could technically keep going and do decimals, but we're not going to worry about that right now. Okay. Now, another way you can report your answer is, well, you can divide it in your calculator. If you do this division in your calculator, you get 228.466, and this 6 is actually going to be repeating because what you get is 228.46666666666, and then eventually 7 if you just, oh, I did not mean to put that one there. 7 if you decide to round up at a certain point, okay? One more kind of creative way to report your answer is if you kind of think about the relationship between the remainder of 7, and this decimal. Well, what am I dividing by to begin with? This 15. So a slick way to report this answer is 228 plus 7 over 15. Okay, 7 is my remainder and 15 is my divisor. Now you're probably sitting here like, why would you do that? And I don't believe you. I don't believe you that that's true. Well, do 7 over 15 in your calculator. Okay, that's going to give you 0.46666666, and if you decide to round up, 7. I don't know why I keep putting that there. Sorry. Okay, and then when I do 7/15 plus 228, I get this. Ooh, I get this. I get this. There we go. 3rd time's the charm. All right, so these are all different ways to report the answer. And actually, when we do polynomial long division, this is the way that we actually prefer as mathematicians, because this kind of tells us a better idea of what the remaining piece is, okay? So a little skeleton to kind of, like an answer skeleton to remember, is that whenever we do division problems with polynomials, you're going to want to report your answer as the quotient, so the thing you get on top of the little house when you do division, plus the remainder. If there's a remainder, right, there isn't always a remainder, divided by the divisor. Okay, so this is going to be your little skeleton, your little template for the way you're going to want to report your answers when you do polynomial long division, right? Any normal person would use this whenever you do this right here. And then in elementary school, you did this one up here because you cared about the remainder. But now we're going to be funky and use this remainder over divisor way, okay? So let's do an example, okay? And then just to kind of, actually before we do the example, to kind of preface this, we're going to discuss pros and cons of this long division versus tomorrow's or our next lesson in 5.5b, the synthetic division, okay? So right now, right off the bat, a pro, like a positive thing about polynomial long division is that it works every time. As long, I guess I should put an asterisk here. Works every time. Asterisk being as long as you do it right. As long as you do it right. Okay, as long as you don't mess any signs up, as long as you don't have any little calculation errors, it always works. Whenever you do long division, it will always, always, always work. Now the con is that it's kind of tedious, and by kind of tedious, I mean really tedious, okay? And you're about to witness what I mean by that, okay? So let's see for ourselves how tedious it can be, okay? So for example 1, we're going to divide 2x to the 4th plus x cubed plus x minus 1 by x squared plus 2x minus 1. Okay, so we're dividing by this. This is our divisor. Okay, whatever we divide by is our divisor. And this is the dividend. Okay, when we do long division with polynomials, we'll set it up the same way. We'll have, I'm going to try to do different colors. So we have x squared plus 2x minus 1. That's our divisor, so that goes outside of the little house, the little division symbol. I don't know if there's like an official name for it, so I apologize. Like there is a radical, right? We call that a radical. I don't know if there's a name for this. Come up with your own name and tell me when I see you in class next time. Okay. 2x to the 4th plus x cubed plus x minus 1. Make sure you leave room up here for the, hopefully remember that this is called the quotient. Okay. All right, let's do this step by step just to see kind of where everything's happening, where everything falls into place, okay? So just like with the numbers, we're gonna ask ourselves how many times the 15, oh, I apologize for that. The 15 goes into, it couldn't go into 3, so we moved to 34. This is kind of similar. So we only ever care about the first term of the divisor, so the x squared. So we need to figure out how many times does x squared go into also the first term of the dividend. How many times does x squared go into 2x to the fourth? Well, to figure that out, let's do that. 2x to the fourth divided by x squared. This is why we did 5.1, so you guys could do your polynomial, or sorry, so you guys could use your exponent properties in this situation. Okay, 2 divided by, in this case, 1, that's just 2. X to the fourth divided by x squared, that's going to be x squared. So that's how many times. Oh, let's back up a little bit. I made a little bit of an oopsie, sorry. Not a huge one. So I forgot, whenever you put your dividend inside, and it also applies to your divisor, but our divisor is okay in this case. Notice that in our dividend, we're missing a term. We're missing x squared. Okay, so whenever you're missing a term, use a placeholder. So what I mean by that is if you're missing the x squared term, you actually want to put in here a 0x squared and then continue plus x minus 1. So let's make a note. And I'll put it in a different color. So note, use placeholder for missing terms. Okay, I apologize for that. It completely escaped my mind. Okay, so you want to make sure that you're using a placeholder. So in this case, we're missing the x squared term. Okay, so then we use the 0x squared as our placeholder. All right, I apologize for that. Sorry for the interjection. Okay, back to business. So this is still correct. It wasn't like this was incorrect. The reason why I remembered is because now, since this tells us that x squared goes into 2x to the fourth, 2x squared times. Since it's the x squared, we're going to line that up with our x squared place. So 2x squared goes here. And then now what did you do with the 15 once you figured out how many times it went into it? You multiplied it by that number. So 15 went evenly into 34 twice. So then I did 2 times 15 and subtracted 30. So I do the same thing. I do 2x squared times this. So I'm doing the math on the side. So 2x squared times my divisor, x squared plus 2x minus 1. What does that give me? 2x to the fourth plus 4x cubed minus 2x squared. And this is what we're going to subtract off. So let's subtract that off. Minus that whole thing. So minus 2x to the fourth plus 4x cubed. And you want to line it up with the like terms so you know you're subtracting the like terms. Minus 2x squared. Okay, and we're subtracting this, so we have to be careful. 2x to the fourth minus 2x to the fourth, that's gonna cancel out. Okay, because they're the same. X cubed minus 4x cubed. That's going to be negative 3x cubed. Okay, and then 0x squared minus negative 2x squared. That's why we need this placeholder here to show you that there is something that we're taking from or adding to, depending on what it ends up being. In this case, it ends up being adding to, because 0x squared minus the negative 2x squared, that becomes plus 2x squared, so plus 2x squared. Okay, so then now we bring down our next term. Let's bring down that plus x. Okay, notice that mechanically it's all working the same way, right? The way we would do long division with numbers. Now there's just letters and addition and subtraction involved, okay? Nothing that we can't handle though. You guys got this. So then now, same thing. How many times does x squared go into negative 3x cubed? Okay, if you need to do that math on the side, do it. Negative 3x cubed divided by x squared, that's going to be negative 3x. Okay, so then I do negative 3x times x squared plus 2x minus 1. Oh, first of all, since I know how many times it goes into it, minus 3x right? And I lined that up with my x term. Okay, so then negative 3x times this, we get negative 3x cubed minus 6x, that should be an equals, sorry, minus 6x squared plus 3x. Okay, we're subtracting this off from here, so let's do that. Minus, let me do it in blue actually, minus negative 3x cubed minus 6x squared plus 3x. Okay, we're going to chop that off. Negative 3x cubed minus itself, that's going to cancel. Goodbye. 2x squared minus negative 6x squared, that's going to be plus 6x squared. So 2x squared plus 6x squared, that's 8x squared. X minus 3x, that's going to be negative 2x. Sorry, I spaced out there for a second. Okay, almost done. We're almost there for this problem. Bring down the minus 1. Okay, so then now, again, the first term with the first term. How many times is x squared go into 8x squared? You probably don't need to do the division to know that it's just 8, right? What do I multiply x squared by to get 8x squared? 8. So we do 8 distributed into that x squared plus 2x minus 1. That's going to be 8x squared plus 16x minus 8. So we subtract that off. Do it in blue. Minus 8x squared plus 16x minus 8. We're chopping that off. So this cancels out, right? Because it's 8x squared minus itself. Negative 2x minus 16x. So that's negative 2x minus 16x. We get negative 18x. Negative 1 plus 8, that's going to be plus 7. Okay, and now we would keep going, but we would ask ourselves, how many times does x squared go into negative 18x? Once you get a degree, once this degree is smaller than the divisor degree, you're done. You can't go into it any further. And actually, I forgot to put the plus 8 up here, right? Because that's how many times x squared plus 2x minus 1 went into this. It went into it 8 times. Okay, so we did it. Now let's report our answer. What's the answer here? Well, remember we follow that template. So equals our quotient, so 2x squared minus 3x plus 8 plus remainder, so negative 18x plus 7 divided by our divisor, so x squared plus 2x minus 1. And this is our answer. Woo, that's crazy, right? So this is our answer. Let's go ahead and do a few more examples so you get the hang of this, right? This is the first time we're doing this with polynomials. So half of us are like, well, I barely remember how to do it from elementary school with numbers. You expect me to know how to do it with polynomials? Eventually, yes, right? So meet me in the next video where we'll do a few more examples, okay?